Hello everyone, I'm Christina, and in this video we're looking at question 14 of the Edexcel 2018 paper 1 for A-level mathematics. So let's have a read through the question and then answer part A. So we have a curve that has these parametric equations. And for part A, we want to show that all the points on C, which is defined by these expressions for x and y in terms of sine t and cos 2t, satisfies this equation here we have just in terms of x and y. The easiest way to do that would be to substitute in these expressions into this equation, and for us to show that the left-hand side is equal to the right-hand side. So let's do that. 14a. So if we're starting with y equals 6 minus x minus 3 all squared, because we're trying to show that this equation is holding, let's now replace x and y with our expressions that define the curve C. So these are our parametric equations. So instead of y, we're going to write 4 plus 2 cos of 2t equals 6 minus. Now, instead of x inside the brackets, we're going to substitute in 3 plus 2 sine t. 3 plus 2 sine t minus 3 all squared. We can see clearly here that the 3's cancel. So plus 3 minus 3, that's 0. So what's left here? 6 minus 2 sine t all squared. Of course, on the left, we still have 4 plus 2 cos 2t. Now, we don't want to move the terms on the left to the right or from the right to left. So we're not solving this equation. We're just showing that it holds. The equality here holds, and that the points on C are satisfying this equation. All we want to do is we want to show that the left-hand side is equal to the right-hand side. So from here, we want to try and express the right-hand side in a way that matches the left. Or perhaps the left-hand side needs to be rewritten so it matches the right. One thing we should do is maybe multiply this out, get rid of the brackets. So 2 sine t all squared, that's going to be 4 sine squared t. So I think the easiest thing to do would be to focus on the left-hand side, because there is a way for us to rewrite cos of 2t, and it's going to be using the double angle formula for cos. So let's use that. We know that cos of 2x can be expressed as follows: 2 cos squared x minus 1. But another common way to express it is 1 minus 2 sine squared x. Now, this is the one I'm going to choose. This is the double angle formula I'm going to use, because there's a sine squared t on the right-hand side. So it might be useful for us to then also have a sine squared t on the left as well. And that way we can see if they match. So 4 plus 2, so now we're rewriting this, cos 2t. Cos 2x is equal to 1 minus 2 sine squared x. That's our double angle formula there. So then all we have to do is use t as our variable instead of x. So we're going to write 1 minus 2 sine squared t. So now let's multiply out what's on the left-hand side. So that's 4 plus 2 minus, that's 2 times minus 2, that's minus 4 sine squared t. So we can simplify a little bit by adding up 4 and 2 here. So that's 6 minus 4 sine squared t. And immediately we can see that's exactly what we have on the right-hand side. So you can rewrite it. And we can see the left-hand side. You can just write a statement acknowledging that the left-hand side is equal to the right-hand side. Therefore, curve C, all points on curve C satisfy the equation y equals 6 minus x minus 3 all squared. Okay, so in the next video, we're going to look at part B of this question.